We are on 2A.2, so we're going to call it operation with function notation. Okay? Yes? We're good? All right. So do not write down the next two slides. Got it? Function notation. It's not pretty because I just made it. Function notation is anytime you're writing, instead of a y, you're writing f of x or g of x, right? That makes it function notation. Got it? Anytime instead of writing y, I write f of x, g of x, h of x. Functions can have different names, just like all of you have different names, correct? All right. Function notation just defines your f, the name of your f and g. It's just defining your output, saying this is from function f, this is from function g, this is from the r, because I was describing radius, right? That is all function notation is describing your dependent variable, okay? In terms of your x. Math operations. These are our 5 math operations: addition, subtraction, multiplication, division, and composition, because we just now talked about composite functions, correct? So these are our 5 math operations, okay? These 5 operations can be written in function notation. Got it? We're going to go through putting it all together, okay? Still not writing yet. Got it? All right. When you're in addition, addition can be written like this in function notation: f of x plus g of x, or f plus g of x. It's telling you to combine the two functions through addition. Do we see it? Subtraction can be written like this: f of x minus g of x, f minus g of x. Okay? Multiplication can be written like this: f dot g of x, or f of x times g of x, or 3 times f of x, right? A number on the outside, any number on the outside. I just chose 3. No, not yet. Oh, I can count 3. I knew that. Make sure you knew that. Okay. I just told y'all I had to make up notes for first period. No, right. First 3 slides, correction. Okay. Division. Division looks like this. Okay. Division is saying f of x divided by g of x, or f slash g of x, right? And last is our composition, which is what we've been learning to do all week, right? Yes? All right. Now you're going to write. Are you ready to write? Yeah. So up first, we're going to dive into addition. Okay. So for addition, we're going to practice writing it in function notation, or reading and applying function notation. So for addition, it's saying I'm going to take f of x plus g of x. Well, what is f of x? And f of x is 2x plus 1. So what does that mean I'm going to do? I'm going to take f of x and substitute in 2x plus 1. Plus, now I'm going to substitute in g of x. What is g of x? Plus 1. I'm going to simplify and combine like terms. Simplifying means to get rid of parentheses. So that leaves me with 2x plus 1 plus 1 plus x squared. Why did I do that? Just because I wanted to be able to circle my 1s in a minute. Why am I going to circle the 1s? They're like terms, right? So these are going to be combined. So my final sum is going to be x squared plus 2x plus 2. How do you feel about function notation with addition? Is that 1? Is that plus 1? Or is that plus 1? Yes? No, I'm saying, how do we feel about it? Oh. Sure? Doable? We're just taking one function and adding it to another function. That's it. That's all it's asking you to do. So when you see f of x plus g of x, or f plus g of x, you're just adding the 2 functions. Okay? Do you think that's going to change for subtraction? No, it does not. So go back to what? your f of x and g of x are going to be the same the entire time. So if you want to just write it once and apply it, it's up to you. What's going to change is their rules. All right. So for subtraction means that you are taking your f of x and minusing your g of x from it, correct? So f of x minus g of x, or written as f minus g, looks like this. We have 2x plus 1 minus x squared plus 1. The difference between addition and subtraction is that with subtraction, the subtraction has to be distributed. Meaning that this negative goes to this term and to this term. So we have 2x plus 1 minus x squared and minus 1. Now we combine our like terms. What are my like terms? The ones. I have a positive 1 and a negative 1. What's going to happen? They cancel each other out. So all we're going to be left with is negative x squared plus 2x. All right, talk to me. No concerns? No? Well, this is in first period's defense. I just sent them to the scavenger hunt with no notes, and they saw this and they didn't know what to do. They didn't have the notes. Well, this wasn't in notes. This was just they didn't. Okay, just first period is not your fault. Ignore your peers. It's me. I'll take it. It's on me. All right, multiplication. Ways that multiplication can appear in function notation. Okay, so it can look like, do you remember our multiplication dot? So f times g of x, or it can be f of x times g of x, or it could be a function times any number. 3 is just any number, right? Okay, so here, if I'm telling you to multiply, so if I want to find f of x times g of x, that means I'm doing what with f of x and g of x? Multiplying. So we have 2x plus 1 times x squared plus 1. How do I multiply those? FOIL, double distribution, right? So when we double distribute, 2x times x squared is 2x cubed. Remember, when you are multiplying variables, you're adding their power. So 1 plus 2 is 3. 2x times 1 is? I'm good. And then we have 1 times x squared is? It's just 1x squared. And then 1 times 1 is? 1. And now we combine like terms. There are no like terms, so we just write it in order of decreasing power. What is my highest power? 3. Then who's next? 1x squared, and then we have 2x and 1. Okay, how do we feel about multiplication? The more terms there are, the more times we have to distribute, right? That logically makes sense. Everything can be multiplied. Yep. Good. Questions, comments, concerns about multiplication? All right, let's keep it pushing. All right, division. So if we have f of x divided by g of x, or f of g, I mean f over g of x, That literally means we're taking f of x and putting it over g of x. That's it. What's our f of x? 2x plus 1. What's our g of x? Do they have anything in common? They have no common factors. That's your answer. Can't go no further. If there is no common factor, meaning that in each term they're all divisible by 2 or all divisible by 3 or all divisible by x, then that's where I stop at. They can't be eliminated. That's you only can eliminate factors, which means that it's being multiplied, not anything that can be added or subtracted. We'll work on it today and when we come back. All right. Last but not least, do we need to review composition? Or are you feeling pretty good about composition? This is what we've been doing. Just review. Okay, I heard review, so we'll review. Go back. Oh, we only needed one page? Did it all fit on one page? Oh, okay, then only one page. Oh, okay, good. I'll erase that. All right, so here we go. Composition, f composed of g of x, which means I'm taking g and plugging it into f, right? So f composed of g of x. What is g of x? What is g of x? X squared plus 1. So that means into f, wherever there's an x, it becomes what? It's going to become x squared plus 1. So we have 2x, but instead of x, it becomes x squared plus 1. Plus 1. So again, remember, the key thing is it's just replacing wherever x was, 2, 2, 2. That's your input. Do, do. And everything else is going to stay the same. Now I'm going to simplify, so I distribute. And we get 2x squared plus 2 plus 2 plus 1. You see nothing. And what is my final answer? 2x squared plus 3. Okay. Bam. Those are all the skills that you need for your scavenger hunt. Do we have them? Feel good? Okay, so correction, only on page 57, 67. Yeah. Good job, guys.